Just real quick though, let's see here. Let's go ahead and, I've sent you out an email and stuff, but let's just see if we have any questions about preparing for the exam. So let me switch screens here. I think this might be the screen. So anyways, exam material, exam prep material, it's in the middle of the lesson page titled Semester and Final Exam Resources. So the stuff at the top is from when we were preparing for the semester exam, so you got to scroll down a little bit. And this is a short video basically telling you what I'm getting ready to tell you right now, I guess. So we want to start with, on Tuesday we'll test, we'll do the fill in the blank vocabulary and theorem test. So that's, if you haven't looked at it already, that's a file with a word bank. And then Jordan had a good question yesterday. That the words that are in the word bank, just make sure you know those are words that'll fill in the blank for the theorems, and words that are their vocabulary terms. So, not all the words you see in the word bank are going to be, you're going to have definitions for, like maybe a segment or something. You might not have a definition of that. Okay, so I just have to leave that up to you to differentiate between the two. And then below the word bank, you see a table that has the chapter and sections where the postulate and theorems are coming from, so that you can go through those chapters and sections and make sure you didn't miss filling in the blanks for any of the postulates or theorems. And some of them, on the test are not word for word, but the general idea is there. And then I have two practice tests, so to speak, or study guides. It's called a study guide here, but they're practice tests. This one is a little more direct, less, higher order concepts of piecing things together. It's like 60 to 65 questions. And then this one is like 38 questions, but there's more involved as far as concepts and putting things together. So you need to do both of them because when you get to the exam, I'm pulling from both of those. So let's just say there's 100 questions. If you do 20 a day, testing them, going over them, reworking, figuring things out, you should be okay. Because again, remember, we're not going to do the second part of the test, the written part of the test on Tuesday. We're just going to do the vocabulary part. So there'll be another day that I haven't set that date. Maybe next Thursday or Friday. We'll take that other exam. I'll have to get back with you on that. So just pace yourself, make a plan for yourself and go through all those. You see a couple of videos here, a few videos here for problems that go to this study guide here. I may make some more videos depending on what kind of questions I get from you guys. So that's that. Any questions before I switch screens?
Are we gonna have to turn in the preparation test for the final exam?
No, it's just you're going to have to just self-govern yourself, and you're going to do that on your own. I'm not going to ask for any submissions. But if you guys find something that you're after you've done it yourself and you've looked at the solutions and you're still not getting understanding on it, then feel free to email me or text me or something, and we can arrange further help.
Just one more thing really quick. I wanted to let you know that I'm working on the test, but my practice test is turned in, so.
Yeah, I'm aware of that. I just graded your practice test.
Oh, okay. I didn't see that. Sorry.
No, I just graded it just before we got on here.
Okay.
And then I'm seeing a question here from Jordan. How many questions for the exam? It's 60 or 65. Okay. And then, we've already done the semester exam. That's what we did before Christmas break. And then that's the halfway mark, semester being the halfway mark. And then we've got our final exam. So those two tests together, count for 20% of your final grade. All right, any other questions before we switch over? Okay. And about the semester exam, you know, there's one video there as far as if you find something from the first semester that you're still having trouble with, but that's just one video. All right, so let's switch screens. Okay, if you haven't caught up with your emails, there is I did a video yesterday. I posted a video yesterday going through the whole concept of determining the number of faces and vertices and edges, went through Euler's theorem and so forth. So there's a video up on there on that. All right, so number one says, how many vertices does the polyhedron have? Okay, so you have to understand the definition of a vertex. This is a net. Remember, a net is a two-dimensional representation of a three-dimensional figure. It's you're opening up, you know, a cube or some type of prism or something. I also, again, if you missed it, I also posted a couple videos going over the vocabulary. This is a pretty vocabulary-rich section. So anyways, in this problem here, we have two options of determining the vertices. We could count them, or we can use Euler's theorem. But, you know, in counting, we have to realize, okay, vertices are, you know, where three or more segments or sides come together, okay? So if we were to count them, you know, hold on, I've got to get my tablet on. You know, if we were to count the vertices, okay, so you have, like, for example, well, let's find where's one at. Looks like the vertices are in blue. Or no, those are the edges. Okay, I don't have the vertices counted. But the vertices would be like 1, 2, 3 sections coming together. So there's one, you know, so here, you know, these two, you know, these two corners coming together would be another vertex and stuff when you have it in 3 dimensions, okay? So I'm not going to go through all the counting of it. You know, it's easy to, but let's look at using the Euler's theorem. So what I'm going to do, for me, what's easiest is, okay, I can determine the number of faces. Remember, that's the polygons. You got 1, 2, 3, 4, 5, 6. And I showed you in the video an easy way to determine the number of edges. Okay, remember the definition of an edge is where two sides come together. So for example, where the side of this face comes together with this face when you fold it up to 3 dimensions, that's an edge. Okay, so for every edge, there's 2 sides of the polygons that make up the polyhedron. So if I could take the total number of sides of, you know, created by all the individual squares in this case, I can just divide that by 2 to get the number of edges. Okay, so in this case, we're dealing with squares as opposed to octagons or something like that. So a square has 4 sides. So 4 times, and we have 6 faces, so 4 times 6 is 24. We have a total of 24 sides. And then we're going to pair them up because 2 sides make an edge. So 12 divided by 2, or 24 divided by 2 is 12. So there's 12 edges. So notice in Euler's theorem, there's 3 variables, and now I have 2 out of the 3, so I can solve for the third. So because I've got the faces and I have the edges, and so I can plug that into Euler's theorem and solve for the number of vertices. Okay, and we have 8 vertices. That is correct. Okay. So again, to me, that's easier than trying to mentally count them. All right. Any questions on that? Yep. Okay. Number 2, below is a net of a polyhedron. Okay. Again, so if we folded up these triangles, we'd have a triangular polyhedron. And says how many edges does the polyhedron have? So we could do exactly what we just did with number 1, and we can count out the total number of sides. We have 4 triangles with 3 sides each, so 4 times 3 is 12, divided by 2, so we have 6 edges. All right, so now we're going to get into using some formulas. The surface area of the regular prism below is 606 square yards. Solve for x. Okay, so x, so I'm going to call 7 the height, and x the length of well, I've got base because of our formula here. And then we have width, okay? So x would be the length of the base. Okay, hold on, I'm reading a chat this. Okay. So on your reference sheet, you have, I think, 2 different formulas. So first of all, let's talk about surface area. Surface area is the sum of the areas of all the faces. Okay, so I took the area of the, if I wanted to individually, I could take the area of the 2 top rectangles and so forth, and the 4 side ones, and add them all up together. So these 2 formulas are basically the same thing. This formula here is capital P, that's the perimeter of the base, okay? That P stands for the perimeter of the base, and the capital B stands for the area of the base, okay? And so we could either use one of these 2 formulas, okay? Base B times H, that's just, again, that's like the length, okay? Let's see what formula I used. I've got it showing both ways. So first of all, to use this formula, I'm going to find capital P. Remember, again, capital P is the perimeter of the base, which I'm going to call this the base. So perimeter, this is a rectangle, so opposite sides are congruent. So I got 7 and 7, x and x. Okay, we're solving for x. So what we're going to do is we're going to, we've got the surface area, so we'll plug in what we know into our formula, and we'll have an unknown that we're solving for. So again, the perimeter can be represented as, you got 2 7s, so that's 14 plus 2x. And then the area of the base, remember the area of the base is length times width, so that's going to be 7 times x. Okay. And then the height, okay, the height of the prism is 15. Okay, that's what h represents. So again, I've got this w, this b, and this h for if I was using this formula. Okay, but I'm working on this formula right now. Anybody have the reference sheet in front of you? Does it have both of those formulas, or does it just have, what does it have? Okay, the first thing on your reference sheet, you have to be able to recognize, hey, this is a prism, okay? Because your formulas are going to be probably categorized as a prism and so forth. And that may be what Jordan's referring to. He looked at the wrong formula. All right, so I'm assuming nobody has their reference sheet next to them. All right, so we've got our values. We've got the capital P, we've got capital B, and we understand h is the height of the prism. Remember, the height's going to be perpendicular with the base. So then we're just going to plug in our numbers. We know the surface area, so I'm plugging in 606 for the surface area, substituting capital P with 2x plus 14, the height with 15, capital B with 7x, and when I solve for x, I get 9. Okay, and then this over here is using the formula 2 times length times the width plus 2 times the length time, or 2 times the length times the height plus 2 times the length times the width plus the height times the width 2 times. All right, so 2 different ways. All right, so what did you do, Jordan?
Well, you know how like on the first question it has the box opened up,
Right.
second too. So I did that, and then I I just opened it up, and then I used the like areas of those boxes that I could find, like the smaller boxes that I could find. I used those, and then subtracted it from the whole area, and then figured out what times 15 times, what times 15 times 2 plus 7 times that would equal up to what the thing was.
Oh, very good. That's
Yeah.
sounds like extra work, but that's good as far as you being able to come up with your own plan. That's good. Very good. Okay, so Jake's saying on the sheet it doesn't say that, it says this. Okay, that's better. I must have copied what I did from a different version. He's showing it says 2 times the length times the width plus 2 times the height times the width plus 2 times the length times the width. Okay, so it doesn't show 2 times the capital PH. It doesn't show that. That's what the book uses. I know that, but it doesn't have both in the reference sheet, huh? All right, so just be familiar with using that formula then. 2 times the length times the width plus 2 times the height times the width plus 2 times the length times the width. So that's good, Jordan, that you figured that out, especially with that unknown variable for that dimension. All right, so that's that then. And I will go ahead and make a PDF of this to refer to, and then if anybody wants to see the video, I can send that to you too if you ask. All right, number 4, Joe is, hold on, let me move my chat box here. Joe is going to cover his fiance's gift box below with 10 karat gold wrapping paper at 50 cents per square centimeter. If he only covers the lateral surfaces, how much will he pay for the wrapping paper? So we need to recognize a couple things or know a couple things before we come up with a plan. One, what it means by lateral surfaces. He's only covering the lateral surfaces. And remember what I said about lateral area. That's everything but the bases of a prism or a solid. Okay, so that means he's just going to cover the triangular parts. He's not going to cover the bottom, the base. And then, he's paying 50 cents per square centimeter. So square centimeter, we need to recognize that we're dealing with area. And since it's just the lateral surfaces, we need to find the lateral area of this pyramid, and then however much that is, however many square centimeters that is, multiplied times 50 cents to determine the cost. So if you take your formula, surface area times 1 is equal to 1/2 times capital P, so that's the perimeter of the base, times the cursive L, that's lateral height. Remember we said the lateral height is the height of the triangular face. And then notice I've got capital B, or the area of the base, crossed out because we're only concerned with the lateral surface. So we don't need to find the area of the base. Okay. And so Jake's telling us again that that's a different formula. I'm not sure if I have it down at the bottom, but so this capital P, it would probably be, that's giving you you've got 4 triangular faces, so you need to find that one triangular face would be 1/2 times the base of the triangle, base length, which in this case is 8 centimeters, times the height, which is 10 centimeters. So the area of one of these triangles is 1/2 times 8 times 10, and then you have 4 of those. So you multiply it times 4, that's the same thing as getting the perimeter and multiplying times the slant height. So I'm not going to ask you to type in what the formula the reference sheet gives you, Jake, but just you guys make sure you can make a distinction between the two. So again, I've got the perimeter, what's the perimeter? 8 times 4. What's the area of the base? It's a square, so 8 squared is 64. The slant height is 10. Okay. So again, we're not concerned with the area of the base because we are only concerned with the lateral surfaces. So we find that we're covering 160 square centimeters at 50 cents per square centimeter. So it's going to cost us $80 to wrap our wedding gift here, our engagement ring. Let me see if I can find a reference sheet real quick, if I got an extra one. Oh, yep, I've got one here. Yeah, it's different. So we got like the reference sheet says, let's see, what's a cursive L? Slant height L is length. It's different. So just make sure you can, if you want to, as you're going along with this, if you want to write the formula that I'm showing on your reference sheet, you can do that as well and use that on the test. So again, I'll put the PDF of this up on there, and if you want to again write this alternative formula that I'm using, you can do that. All right, number 5, Wanda has a cylindrical fish tank with a hemisphere, that's a half a sphere, as a dome on top. The cylinder's base has a diameter of 4 feet. The height of the tank is 6 feet. What is the total exterior surface area of the tank? Okay. Exterior, so that would exclude the base at the bottom. Okay. And so, this one's a tough one because you have to visualize a couple things. The cylinder's base has a diameter of 4 feet, and the height of the tank is 6 feet. So that's from the base to the tip, to the very top of the hemisphere is 6 feet. That's important to make the distinction because we need to find, in order to find the surface area, we're going to, we don't have a formula for the surface area of a figure like this, of a solid like this, so we'll have to do it individually. We'll have to find the surface area of the cylindrical part, and then separately this surface area of a cylinder, of a sphere. Okay, so we have to recognize, okay, the whole height is 6 feet, so then the radius of the sphere must be 2 feet. Okay, because the diameter of the the cylinder's base has a diameter of 4 feet. Okay, and so that sphere is going to have the same diameter, the same radius, because it's going to, what fits on the top is going to have to be the same size as what fits on the bottom. All right. So what's the plan? Find the surface area of the hemisphere, find the surface area, the lateral surface area of the tank, because again, we're talking about exterior. So I guess that would include the bottom base, but not the top base because it's inside the tank. All right. So surface area of the sphere, we could find the surface area of the sphere using this formula and then take half of that because we're dealing with a hemisphere. And then we could find the surface area of the cylinder. Notice here, pi r squared, that's the area of a circle. And then we've got the 2 there because of a cylinder, we have 2 circular bases, top and bottom. But since we're only concerned with the exterior, we're only concerned about the bottom base. So that's why that 2 is crossed out. Okay. So again, if we need the radius of the sphere, that's not given directly. But if we recognize, okay, hey, this circular base has a diameter 4, and that diameter has to be the same as the diameter of the sphere, So then the radius of that sphere is 2, so that gives me, 2 here and then 4 here. The height of the cylinder is 4 feet. Does that make sense? Are you guys with me?
So you don't count the base?
One of the bases. So I misread it the first time. So what is the total exterior surface area? That means outside. So with this tank, the bottom base is outside. It's on the outside of the tank. But
Okay.
if we're going to have a tank, then this is going to have to be hollow here. So there's no circular base here.
So after you take the part of the sphere, is the remaining like cylinder part would be 4 feet on the side?
Yeah, because they're telling us the total height is 6 feet. All right, and we know that the height of the sphere is going to be 2 feet because we have a diameter of 4. So from the center up to the top, that would be a radius. So we have a radius of 2 feet. So I take that 2 away from 6. That must be the height of the cylinder. And the reason I'm saying that because I need the height of the cylinder to find the surface area. All right. Okay, so we are running out of time as far as our free 40 minutes. And so now that we know our values, we can plug them into our formulas. And notice with the surface area of the sphere, I'm dividing that in half because I only have a hemisphere. And so I get the surface area of the hemisphere and the surface area of the cylinder, with the exception of the one circular base, add them together, and I get 87.96 square feet. Okay, one of the other things that may not be apparent is what happens when you double or you triple dimensions. What happens to the surface area or to the volume? So for example, with number 7, it says if you double the diameter of a solid sphere whose diameter is 3 inches, how many times will the volume increase? So if you look at the volume formula for a sphere, notice that you're cubing the length of the radius. Okay. Did I skip one? Somebody's saying, what about 6? Okay, same thing here. Okay, so let's look at number 6. In which way can you double the volume of a circular cylinder? Circular spelled wrong. So if I look at the volume formula for a cylinder, I've got pi r squared h. Okay. If I double the radius, I'm actually quadrupling the volume. Okay, because let's say the radius is 2. Okay, and I double that to 4. So if it's 2, the radius squared, that's 4. If I double it, the radius is 4, and 4 squared is 16. Notice I'm quadrupling that. Okay, so you need to be able to distinguish that. Whereas if I double the height, I'm multiplying the height times 2, so I'm multiplying everything else by 2, so I'm just doubling the volume. Okay, so for example, 2 times 3 times 4 is 24. If I double one of these numbers, like let's say I double 4, 4 times 2 is 8. So now I've got 2 times 3 is 6 times 8 is 48. Notice by doubling one of the factors of the product, these are factors that are 3 factors that make a product. Notice if I double one of the factors of the product, I'm doubling the actual product. Okay. Even if I double the 3, I'm still doubling it. So by doubling the height, I'm multiplying 2 times the entire volume. Okay. Another way to look at it is, let's just start with a radius of 1. Okay. Or a height of 1. The volume would be pi. Now let's double the height. Let's go from 1 to 2. And notice what? I've got twice the volume. Okay. So I'm kind of going fast because we're running out of time. In this case, if you double the diameter of a solid, how many times will the volume increase? Okay, so if I'm doubling the diameter, I'm also doubling the radius. Okay, so the way I look at it is, okay, that this radius in the volume formula is being cubed. So that 2 that's being multiplied to whatever the radius is, it's also being cubed. So 2 times 2 is 4, times 2 is 8. Okay, so by doubling the diameter, I'm increasing the volume by 8 times. Okay, so what you see here is an example. Let's say I've got a radius of, if I have a, well, not an example, we're actually just playing it out. If I have a radius, the diameter is 3, so the radius is 1/2. Okay, so if I plug that into the formula, I've got a volume of 4.5 pi. All right, if I double that from 1.5 to 3, I've got a volume of 36 pi. 36 divided by 4.5 is 8. I lost my chat box.
Will you post a video of the rest of the answers?
Yeah, I'll post a PDF as too. Jordan, where were you referring to 7.9? Which one? Yeah, it would be exactly 8. It should be exactly 8. So I think what you did is you did what I'm doing here, and you had a value for pi, so you're rounding somewhere, and I imagine what you did, whatever 36 pi is, times 3.14, whatever, you divided that by whatever 4.5 pi is, that estimated value. So that's why you weren't exactly 8. But no, it should be exactly 8. So here's number 8. If every edge of a box is extended by 3/4 its original length, the new box would be what? And then if you look at the answer choices, you're looking at a % of increase of volume. So the way that you can do that is you can test it. Let me just start, let's make it simple myself. Let me give everything a dimension of 1. So the volume of a cube is length times width times height, or a box, a rectangular prism. And so if length times width times height were 1, then I would have a volume of 1 cubic unit. Now let me increase, it says it's every edge of a box is extended by 3/4. So I'm increasing length, width, and height by 3/4, or 0.75. Okay, so when I do that, I have a volume of 5.36. So I've increased that 5.36 times, 1 to 5.36. If I were to put that in percent form, how do you put in percent form? You move it 2 decimals to the right. So that would be 536%. So we'd have a 536% increase. Jonathan's asking in a previous problem, I'm just seeing this, if you double the diameter, wouldn't that be quadrupling the radius? No, it wouldn't be. Let's see what problem that was. So for example, if we have a diameter of 3, I'm not sure if this was the problem. And let's say we double, that would be 6. So if we have a diameter of 3, our radius is 1/2. If we double that to a diameter of 6, what's our radius? It's 3. What's 1/2 times 1.5 times 2? It's 3. So nothing changes. Okay. So we're going to have to stop there. Let's go ahead and let's stop here since these are easy ones. These are just memory-based ones, knowledge-based ones. I can't remember if I put this on the exam or not. When you look at these study guides, the practice test and the study guide, which I call the second one, you'll get a feel for what level of volume and surface area type of problems are on the exam, okay? They may not be as complex as some of the ones that we're looking at. I don't recall requiring you to memorize the tetrahedron and the dodecahedron and so forth, but there's those. And I'll try to remember to double check, or maybe somebody help me remember to see if that's on the test or not. I don't think it is. All right, so I guess in another video I'll have to cover these last three. Let me give you the answer to this one to see if you got it right, and I'm getting ready to get kicked off. You should have gotten, a chat box is in the way, 1,344 cubic inches. So I'll make another video starting with this. Last four, yeah, because we have to do 12 as well. All right. So that's it for that. And I'll start with the PDF, and I'll get that up. I can get that up pretty quickly. It'll take me, I'm not sure when I'll be able to get the video of these solutions up. So from here, you guys can start working on the study guides and the practice test.